Exercise 6.5, first question. Find the maximum and minimum values, if any, for the following functions. That means all are defined on R, it is understood, right? Domain is not given means everywhere they are defined. Now here clearly, this is quite obvious, you see, being a square, this is always greater than or equal to 0. Square of any number is always greater than or equal to 0. I need plus 3. So 2x plus 1 the whole square plus 3 is greater than or equal to 3. Adding 3 on both the sides. This is fx. So fx is greater than or equal to 3. That means value of the function is always 3 or more than 3. What's the meaning of this? That means minimum value of the function, minimum value of f is equals to of f is equals to 3. Minimum value of the function is 3, right? Also, if you want to see, just get the f dash x, differentiation by chain rule 2 into 2x plus 1 plus 0. Fine. And here f double dash, if you find 2 being as it is constant, this is just 2 which is greater than 0. That means second order derivative is always positive. Now whenever second order derivative is positive, look at it, one of the theorem, function always attains the minimum value. And how do you get it? And put f dash x equals to 0. So you'll get the point where the function attains the minimum value. That's a turning point. So 2x plus 1 should be 0. That means x equals to minus 1 by 2. Right? So at minus 1 by 2, function has a minimum value, and minimum value is given by minimum value of here function f of f equals to f of minus 1 by 2. Just put there, if you put there, this will be 0 and this is 3. That's what I have written here. Right? We have justified. Right? You can write up to this also, but this is for your information, I did it. And you can see that here second order derivative is always positive, it never be negative. Always positive means what? Function will have always minimum value. So therefore you can say that here your function f has no maximum value. No maximum value. Clear? Maximum value of the function doesn't exist. I hope this is clear to you. The next question, it's a quadratic expression. You know from integration, every quadratic can be expressed as a sum or the difference of the two perfect squares. And this is very simple. 12x, so here 3 and 2, 6. That means you need one more, so 2. So here 4 minus 2. Adding and subtracting 2, right? This is not difficult for you. We did number of times such things in integration. What is this now? 3x plus 2 the whole square minus 2. Every quadratic can be expressed as a sum or the difference of the two perfect squares. Fine. Now here, you know, being squared, this is always positive, greater than or equal to 0. What I need? I need minus 2. So we just subtract 2 from both the sides. Whole square minus 2 is greater than or equal to minus 2. Subtracting minus 2. This is fx. So fx is always greater than or equal to minus 2 for every x. Right? And therefore what is your conclusion? The minimum value of f, minimum value of f is here equals to how much? Minus 2. The minimum value of f is always minus 2. And there is no upper bound, so therefore you can say that function f has and f has no maximum value. No maximum value. The maximum value of the function doesn't exist. It has no absolute maximum value. Okay, minimum value is minus 2. Right? Now we can do by this way also using that result, right? So what we'll do, we differentiate it. F dash x, what is that? Differentiate it. So it will be 18x plus 12. One more time differentiation, f double dash x, 18, right? Fine. And this is always positive. What's the meaning of this? Greater than 0, that means it will have always minimum value. If it is less than 0, then it has maximum. But this never be less than 0. It is always positive. That means it will have always minimum value. Now, how do you find that minimum value? Or that point where the function has a minimum value? To put first order derivative is equals to 0. So I take x equals to minus 12 by 18. So here, what will be this? Here. So this is minus 2 by 3. So this is the point where the function has a minimum value. Got it? This is the point. This is C as per our theorem. This is the point for which function has minimum value. And what is that minimum value? That minimum value, how do you get that minimum value? Minimum value equals to, put this into the function, f of minus 2 by 3. You can just simplify, you will notice that it will be minus 2. You can just put this one in the function, right? I leave it for you. Put minus 2 by 3 where? In the function. Here or here. You will get the minus 2. So this is the absolute minimum value and it has no absolute maximum value. Right? Two different ways I'm doing for you. Right? This is not important. This is quite obvious because your functions are defined on closed interval. Okay. Now for third one, again this is perfect square. You know x minus 1 whole square is always greater than or equal to 0. Multiply with minus sign. So it's less than or equal to 0. When you multiply with negative number to inequality, this inequality get reversed here. So we have this. Okay, then we'll add 10 on both the sides. So adding 10 plus 10, here 10. Adding 10 on both the sides. Just adding 10 on both the sides. What is this? This is fx less than or equal to 10. And this is true for every x belongs to R. Domain is R, it is understood here. So what you have concluded? That the value of the function is always less than or equal to 10. So therefore, you can say function has what here? Less than or equal to 10. Maximum value equals to 10. Fine. The maximum value of the function equals to how much? 10. Obviously. And f has no minimum value. That's quite obvious here. Okay, here the solution is over. If you want to do by the differentiation, do it. This is for you as I explained in the previous two examples. Here, as far as the question concerned, you are through because the value of the function is always less than or equal to 10, right? So it cannot have minimum value. It goes to minus infinity. So no minimum value. But the maximum value equals to 10. You can try by differentiation as I did in the previous two. Fourth one. Okay. In the fourth one you are given one function gx equals to x cube plus 1. And domain is, it is understood, all real numbers. So being a cube plus 1. So graph will be like this. This is just rough behavior of the graph. Right. At 0 then it is 1, so it passes through 1 and it would be like this roughly, like this. It's a graph of x cube as I have drawn earlier before few minutes, plus 1 I did, so shifting on the y-axis. This is a graph. You see here it never ends, here it never ends. Clear? So you can say here function has neither maximum value nor minimum value, right? It never ends here. This is indirectly parabola. right? All previous three were indirectly parabola, so it has maximum, minimum, but this never end. It's like this, right? It's like straight line. You look at this, for example, fx equals to if I ask you 2x plus 1, so domain is r here. Now what's the graph of straight line? Suppose like this, roughly I'm showing, this may not be right. Now it has, you can see clearly, no maximum, no minimum. It never ends here. It's like that, understood? Graph goes on, so function has neither maximum value nor minimum value. It's like exactly similar to this straight line if it is defined on real number. Question number 2. Find the maximum and minimum values, if any, for the following functions. It's like previous question only. Okay, in this questions you need to understand more than to write. Okay, now recall modulus function. You know, modulus of any expression is always greater than or equal to 0. Subtracting, you know, 1 here, so -1 greater than or equal to -1. This is fx is greater than or equal to -1 for every x belongs to R. Okay, so what's the conclusion from this? Therefore the minimum value of f here is equals to -1. The lowest value of the function is -1. Where it attains the -1, you can just put equals to 0, immediately you will realize. You can draw the graph of this function also very easily. And obviously this is always greater than or equal to -1. So f has no maximum value. Function has no maximum value. It has just minimum value, right? Now we did earlier 4 questions, so you can understand it very easily. Minimum value is -1, no maximum value. Function has no maximum value. Same way, second question. What about second sub question? There the function is given by, again, modulus function. g of x equals to minus x plus 1 plus 3. Okay. Now look at it, modulus. Modulus is always greater than or equal to 0. You need minus sign here. So multiplying with minus sign, you know, if you multiply with minus sign, an inequality, it get reversed because of negative number. Adding 3, so I'll just add 3 on both the sides. Right? We used to do such things to find the range of a function, if you recall. Now what is this? This is function is less than or equal to 3. So value of the function is always less than or equal to 3. Your value of the function is always greater than or equal to -1. So it cannot have maximum value. It goes on. Here maximum is 3. You can see. So it can have anything as an minimum value, goes to -infinity. So how do we write from this? From this, therefore the maximum value of f equals to 3, and f has it goes to -infinity. It never ends. So f has no minimum value. I hope you are clear with this now. Now here you see, by differentiation also it becomes difficult. These are some basic functions, so you need to understand as we were doing in functions. So what's the maximum value of the function? 3. And what about minimum value, right? It has no lower limit. If it is like this, for example, if function is here less than or equal to 3, so this is maximum, and greater than or equal to something, then it is a minimum. You know such thing, sine function, minimum and maximum value. But here there is no lower range. Here there is lower range, there is no upper range. Fine? Okay. Let's go to now third sub question. What about third sub question? What it says in the third sub question? Yes, it is known to you. You did such things number of times earlier. hx equals to, you have sine 2x plus 5. Right? Without using pen, you can answer this question. Fine. So can you think about answer here? Yes, maximum and minimum value you can think of. No need to use derivative. By differentiation it becomes very difficult. It's defined on R, it is understood, real numbers. You know sine theta for any theta is always between 1 and minus 1. You know this. I need plus 5, so adding 5. Minus 1 plus 5. Sine 2x plus 5 is less than or equal to 1 plus 5. Adding 5 throughout the inequality. Okay, now what is this? This is just 4. This is fx, hx, function is h of x, is less than or equal to 6. So, can you recall such things we did in the 11th standard? This is indirectly range. The lowest value of the function, here, function has maximum value equals to 6. This is the highest value attained by the function, and minimum value equals to 4, lowest value. Graph never go beyond less than 4 and more than 6. The graph of this function, you can just Google it and you draw the graph, you will realize the minimum value of the function is 4 and the maximum value of the function is 6. Now this questions by differentiation it becomes difficult, right? So we can answer this way. What about fourth sub question? Let's see that fourth. Yes, that's also like this only. You have there fx equals to sine 4x plus 3 with modulus. Okay. So here it's just question of finding the range. Okay. So we start with this. Sine 4x is always between minus 1 and 1. For any theta, range of the sine function is closed interval minus 1 to 1. Adding 3 throughout. So if I add 3 here, it is minus 2. This is sine 4x plus 3. And here if I add 3, this is 4. Minus 1 plus 3. Oh, sorry. So this will be 2. I'm sorry. Plus 3 minus 1 plus 2. This is function. So 2 less than or equal to fx less than or equal to 4. These are positive number. So even if you take modulus, the values will be positive. So this is a function. So what is this? Minimum value. Minimum value of the function of f equals to 2. Range is 2 to 4 in the other language. And the maximum value of f equals to 4. 2 to 4, that's the range of the function. Lowest value in the entire domain is 2 and maximum value is 4. We are asked to find the absolute maximum and minimum. We are not asked for the local maximum minimum, remember, because here domain is, what's the domain of the function? That is R. Nothing is given, that means function is defined on R here. Now see the fifth sub question. Their domain is different. Yes, in the fifth sub question, hx equals to x plus 1, where x is from open interval minus 1 to 1. Okay, now here you can just do it by differentiation also. This is a straight line, you know very well, right? From minus 1 to plus 1. Right, open interval, that means these two numbers are not included. Okay. If I, for example, think about minus 1, then this will be 0. So it starts from here. If I take 0 here, then it will be somewhere here, and 1 then 2. So it will be like this roughly. Okay, but this 1 is not included here. So I'll just write open circle. 1 is not included. And here minus 1 is not included. Got it? It goes up, it has no turning point. You can see that its derivative is positive. So that means your derivative is 1, which is positive. That means f is increasing function. You know this, right? It will not have any turning point. Graph goes up only. So it's like this. Now how do you determine the maximum value? Less than 1, how do you determine? If it is 1, then you can say that 1, the maximum value is 2. But 1 is not included. Here minus 1 is not included. Look at this. This is open interval and there are infinitely many numbers. Now how do you determine number less than 1? Can you think of 0.9, 0.99? How do you think? That means it has no, therefore h has no maximum value. and simultaneously you can say that fh has no minimum value, neither maximum nor minimum. Are you getting me? See, I'm saying that 1 is not included. So how do you choose a number less than 1? Can you choose 0.9? Then I can choose 0.99 also. Then I can choose 0.999 also. So it's very difficult to determine a number which is less than 1. And similarly here it's very difficult to determine number more than -1 because 1 and -1 are not included. So it has no maximum value, no minimum value. But instead of that, suppose you are given this. For example, same function I'll take, but I'll just take the domain as this. Close interval -1 to 1. Then you can answer it very easily. See, domain is now changed. Close interval -1 to 1. -1, 1. It starts from here and it ends here. So you can say that at -1 it has a absolute minimum. At 1 it has absolute maximum. Getting me? Because here these two endpoints are included. Understood? So here, if it is closed interval, then you can say that f has absolute maximum at 1 and absolute maximum value equals to f of 1. And what is f of 1? Put here, that is 2. So absolute maximum value is 2. And same way you can say that f has absolute minimum value at -1 over here. And what is that value? And absolute minimum value equals to f of -1. It will come from the graph. Put -1 there. What you will get? You will get the 0. But only when you are given the closed interval. Otherwise, no. Right? You understand difference between these and this. The closed interval, open interval. Here it has no turning point, no turning point. The question arises, how do you choose a number less than 1? That's difficult. That's why it has no maximum value, no minimum value. But if I change to closed interval, then it would be like this. In the question number 3, you are asked for local maxima and local minima, if any, for the following functions. And also get the local maximum and local minimum values. Okay, so your first function is this. You know, this is very well known function, parabola, symmetric about y-axis. So it has minimum at 0 here, and that's a local minimum. In fact, it's also absolute minimum, but we'll do with the help of now that result, second derivative test. So differentiate it twice. F dash x equals to 2x, f double dash x equals to 2, which is positive. That means function will have always minimum value, right? This never be negative. That means function will have always minimum values. Now for f dash x equals to 0, that is 2x equals to 0, it implies we'll get the x equals to 0. So this is in our language turning point, right? There is only one turning point. Graph take only one turning point. Which one? At x equals to 0. Now normally we put x equals to 0 and the double derivative. So f double dash 0, but this is always constant, which is 2 positive. So first order derivative is 0 at 0 and second order derivative is positive. What's the meaning of this? From this to these and this, you can say that function f has greater than 0 than minimum, opposite. F has local minimum at x equals to 0. And what's that minimum value? And that local minimum value equals to, you know, f of c, that is f of 0. So put x equals to 0 here, which is 0, right? And this is always greater than 0. To get the local maximum, this may be negative, but here it's never be negative. So you can say that a function, also let me write, the function f has no local maximum value. Got it? Understood? I've used strictly that result, no concept, just that based on that theorem only. What I did first I've differentiated. How many times? 2 times, just differentiated twice. And then for turning point, you are going to put function derivative equals to 0. So I have placed derivative equals to 0. So you are getting this point. That means at 0 the function has a turning point. So local minimum is at 0. At 0 you are getting minimum. And what's that local minimum value? It is also 0. F has no local maximum value. From the graph also it's obvious. Not only that, in fact, you can also notice that this is not only local minimum value, but this is become also absolute minimum value, just for your information. Further, a function has absolute minimum value equals to 0. This is not asked for your reference, I'm telling you. We did it. Absolute, that means this is the lowest value of the function. There is no value which is lower than this, and a function has no absolute maximum value, right? Why? Because it has no local maximum, you can see. So it cannot have absolute maximum value. Graph never ends, it go up and up. So you cannot decide the highest value. Lower value you could decide, which is 0. Fine? Okay, so let's see this now. What is the first task? Differentiate it twice. For local values, this is what you need to do. F double dash, it will be 6x. Okay, so here you see double derivative depends upon x. Okay, now for f dash x equals to 3x square minus 3 equals to 0, it implies you will get the x square minus 1 equals to 0, and therefore we'll get the x equals to plus or minus 1. Fine, we'll get the x equals to plus or minus 1. So these are the two turning points. At 1, first order derivative is 0. At minus 1, the first order derivative is 0. Now where will put this 1 and minus 1? In double derivative. Put 1 here. So 6 into 1. This is greater than 0. So what is the conclusion from this? What is the conclusion? This is greater than 0. So at 1, function has local minimum. Positive means minimum. Therefore, function f has local minimum at 1. Local minimum at 1. And what's that minimum value? And local minimum value equals to f of 1. F of c. Put 1 here. So 1 minus 3, how much? Minus 2. Fine, this is one part. Here, you can do like this in the exam also. Double derivative. Put minus 1 there in the double derivative. So it will be minus 6 less than 0. If it is negative, then maximum value. Then f has local maximum at which place? At minus 1. And local maximum value equals to f of minus 1. Put minus 1 there. So I put minus 1 cube, minus 1 plus 3. So it will be 2 here. Got it? So there are two turning points in this graph. Okay, it's like this. You see, this is not for examination point of view, just for your information I'm showing you. See, the graph would be like this. One turning point at minus 1, the other turning point at 1. Okay, at minus 1 it has a local maximum. So at minus 1 the graph will be like this. Okay, like this, peak point. And then it will be something like this. What about at 1? The graph, maybe it has minus 2 values, so it may be like this roughly. We don't know. It passes through in fact origin like this. And then it will always go up here. And it would always go down. Got it? Rough graph would be like this. At minus 1, it has highest value. sorry, it has, yes, at minus 1 local maximum value, and that local maximum value come from 2. It has to be 2 here, so f of minus 1 is 2. At 1 it has local minimum, you can see here local minimum, and it comes from here, so here it is minus 2, so this is minus 2 like this. Now this graph will never go up. If it go up, that means it takes turning point, then here you must get that point. This will never turn. If it takes the turn, then you will get the turning point, so that point must be here, but there are only two values, that means there are only two turning points at minus 1 and 1, right? This is just for your reference, no need to draw in the exam. Fine? Just to clarify what happened at 1 and what happened at minus 1, just for your information. So in the next question, function is defined in the first quadrant, open interval 0 to pi by 2. What is procedure? Differentiate it twice. You know here cos and minus sign. Again we differentiate it. So here you have minus sign, and differentiation of sign is cosine. So you have minus sin x plus cos x. This is double derivative. Okay. Now as we write like this, for h dash x equals to 0. So we are finding turning points, the points where the function has local maximum minimum. It implies cos x minus sin x equals to 0. So it means cos x equals to sin x. Domain is 0 to pi by 2. So it has to be here what? Pi by 4. Where cos and sin are equal at pi by 4. Cos pi by 4, sin pi by 4 in the first quadrant. Okay, in the second question, in the next question, fourth question, you see the domain there, the domain is different, but here domain is just first quadrant. Okay, now what we'll do, we put this in the double derivative. Procedure is same, h double dash pi by 4. Minus sign is there. This is 1 by root 2. This is also 1 by root 2. This is not important. This is positive, that is important, but you have minus sign in front of this. So here double derivative is negative. Now double derivative is negative. What it indicates? That means function will have, double derivative is negative, that means function, therefore function h has what? Negative means maximum. Local maximum at pi by 4. Fine. Function h has negative means maximum, opposite. Positive then minimum, negative then maximum. And local maximum value equals to, how do we get it? Put pi by 4 in the function. So f of pi by 4. Okay, so this will be 1 by root 2 plus 1 by root 2. Where we are putting? In the function. So it will be just root 2. So local maximum value is root 2 here in the domain here, first quadrant, remember. If it just recall, not for, solution is over here. It has no local minimum value because second order derivative is never positive because you have just one turning point. If you recall, just from 11th standard, you did sin x plus cos x. The maximum value is always root 2 and minimum value is always minus root 2. If you just recall, that's the range of sin x plus cos x, minus root 2 to plus root 2. But why we are not considered? Because your domain is this, 0 to pi by 2. We have just thought of this based on the domain. That's the maximum value. Not only local maximum, in fact it is the global maximum. In fact it is the absolute maximum, but here it is not asked in the question. So we are just using this word local maximum, local maximum. Fine? Clear? Next question. You have this function. So what we do first, we differentiate it twice. Derivative of sine is cos, derivative of cos is minus sine. So plus sine x. Again differentiation. So f dash x equals to, here you have minus sine x. Here we have derivative of sine is cos x. Okay. Now for turning points, we put the first order derivative equals to 0. So for f dash x equals to 0, it implies you have cos x plus sine x equals to 0. Now here we have first two quadrants, 0 to pi. Okay, so sin x equals to minus cos x. That means you have here tan x equals to minus 1 indirectly. Fine. Oh, see, I'm sorry, 0 to 2 pi, that means 1 complete rotation. I'm sorry, not 0 to pi, 0 to 2 pi, that means 1 complete rotation. Okay, so where tan is negative, you know, here tan is positive, here tan is positive. So either second quadrant or fourth quadrant. So what should be your x from this? Second quadrant, here it is 1. So 1 should be pi minus pi by 4. And the fourth quadrant, so other one should be 2 pi minus pi by 4. I hope this is clear to you from the trig. One value is pi minus pi by 4. You need 1 and I need second quadrant, so pi minus something. I need 1 but fourth quadrant, so 2 pi minus pi by 4. So you must have questioned why I've chosen the 2 pi, not the 0. Because you need the positive, that's why. Got it? Here angle should be positive, that's why. You can write minus pi by 4, but as far as this condition concerned, minus pi by 4 is wrong. So either 3 pi by 4 or 7 pi by 4. These are the two turning points. Function takes the turn twice. How many times the function takes turn? Twice. Now very simple. You put this in the double derivative. F double dash 3 pi by 4. Decide the sign. I am placing 3 pi by 4 here. So minus sine 3 pi by 4. It would be here, if you place it, 3 pi by 4 in the second derivative, in the second quadrant, so sine will be positive. It will be 1 by root 2. And cos will be negative, minus 1 by root 2. Just check it. Whatever it is negative. Okay, and therefore what's the conclusion? Second order derivative is negative, therefore a function has a maximum value. So therefore f has local maximum at which place? Local maximum at 3 pi by 4 and local maximum value that is equals to here f of 3 pi by 4. So put f of 3 pi by 4 in the function. Here, this is 1 by root 2 minus minus plus 1 by root 2. So just check it out, 1 by root 2 plus 1 by root 2. So it will be just root 2. That is one part. On the other side here, over here, we have 7 pi by 4. So f double dash 7 pi by 4. Fine? Okay, 7 pi by 4, you know it is 2 pi minus pi by 4, fourth quadrant. In the fourth quadrant, sign is negative. So this will be plus 1 by root 2. And this is always positive in the fourth quadrant. So plus 1 by root 2. This is positive. And therefore, what's the conclusion? What is the conclusion? F has local, positive means minimum, at 7 pi by 4. And local minimum value equals to f of 7 pi by 4. You put this value in the function here. So what we'll get from there? It would be, you can just put there minus, so it will be positive. The other one would be here negative, so it will be minus root 2. So you can just check putting into the function here. This double derivative you are going to put here. So minus root 2. So local minimum value is minus root 2 because here derivative is, double derivative is positive, your double derivative is negative. Negative then maximum, positive then minimum. Fine? At 3 pi by 4 it has a local maximum, maximum value is root 2. At 7 pi by 4 it has a local minimum and that value is minus root 2. So fifth one, that's polynomial function. You are asked for a local maximum or minimum x cube minus 6x square plus 9x plus 15. Okay, so here what we do, what is the first task? Differentiate it twice. So f dash x, which will be 3x square minus 12x plus 9. One more derivative, f double dash x, it will be 6x here minus 12. Okay, Now for turning point, we put f dash x equals to 0. It implies 3x square minus 12x plus 9 equals to 0. You can divide by 3 here before you do the factorization. X squared minus 4x plus 3 equals to 0. So what are the factors? X minus 1 and x minus 3, I suppose. Right? So that means there are two values of x, 1 or 3. So these are the two turning points, right? Where function may have local maximum or minimum. Then what we do? We put this one in the double derivative. F double dash 1, 6 minus 12, it is negative. 6 minus 12, it is negative. Therefore, what's your conclusion from this? Your conclusion will be function f has local less than 0. So maximum at 1. Local maximum at 1 and local maximum value equals to f of 1. And what is that? Put 1 in the function. So if I put 1 in the function here, we have 1. So it will be 1 minus 6 plus 9 plus 15. So it would be how much? 19. That's a value. Okay. So local maximum value equals to 19. Now go to this f double dash 3. Okay. So 18 minus 12 here. 18 minus 12. So it will be positive. So here f has greater than 0 means here minimum. F has local minimum at which place? 3. Fine. Local minimum at 3 here. Okay. And local minimum value equals to here f of 3. So put 3 in the function and simplify. So you will get the local minimum value over here. Just you are going to put 3 here and simplify. So at 1 it has local maximum and local maximum value is 19. At 3 it has a local minimum and local minimum value you can just by find by just putting x equals to 3 here. Okay? Okay, let's see next question. So we just differentiated twice. Here differentiation of this is 1 by 2. Here 2 as it is. Derivative of 1 by 2 is minus 1 by x squared. You know. So here to half minus 2 by x squared. Right? I've used just addition rule. One more time differentiation. G dash x equals to being constant 0 minus 2. This you know minus 2 by x cube, you know very well. So we write 4 by x cube. Okay. Now for first order derivative equals to 0 for turning point, you have this much equals to 0. 1 by 2 minus 2 by x squared equals to 0. First derivative. That means x squared equals to 4. So x equals to plus or minus 2 here, but just plus 2. Why plus 2? You are given that x should be positive. Otherwise it would be plus or minus 2. Now we'll put this way in the double derivative. So there is only one turning point because at one place the first order derivative is 0. Now we put this in the second order derivative here. So it will be 4 by 2 cube. It will be positive. At 2 first order derivative is 0. Second order derivative is positive. So therefore what is your conclusion? The function g has local greater than 0 minimum value. Opposite, greater than 0 then minimum at which place? At 2 here, at 2. And local minimum value equals to g of 2. In the function you put 2. So 2 by 2 plus 2 by 2. So it is 1 plus 1, which will be just 2. Fine. So 7th, gx equals to 1 upon x square plus 2. So I'll just differentiate it twice. What's derivative of this? It's like 1 upon x, and you know it is minus 1 by x square. So minus 1 upon square of this x square plus 2 the whole square by chain rule differentiation of this, which is 2x. Fine. What I did, I've used the chain rule. What's the derivative of 1 upon x? Minus 1 by x square, and then differentiation of this one, which is 2x plus 0. Get again differentiation by which rule here? Division rule. You need to use division rule. Then for turning point, put j dash x equals to 0. So this much equals to 0. So if I put this much equals to 0, I'll just get x equals to 0. Put this one in the double derivative, right? And decide whether it is positive or negative. Now we did so many questions, so you can do that, right? So 0 is the point where function depends upon the second order derivative. If it is positive at 0, then it have local minimum, and if it is negative, then it would have local maximum. But this is the point where the function has either local maximum or minimum. Okay, we'll go to now 8th question, last sub question here. So in the 8th question, the function is, you are given x into root 1 minus x, and it's between 0 and 1 here, open interval 0 and 1. 0 and 1 are not included. We differentiate it, need to use product rule, x as it is. What's the derivative of this one? 1 upon 2 root x by chain rule into differentiation of this, which is minus 1, plus now root x as it is, that expression as it is, differentiation of this one is 1. What I did, I've used the product rule. I repeat, x as it is, differentiation of this one, 1 upon this much into minus 1, plus this one as it is, here differentiation of x is 1. Now we'll just simplify. This is minus x, I'll take LCM here, so 2 root will get cancelled, 1 minus x upon 2 into root 1 minus x. What I did, simply LCM, minus x as it is, taking this much over here, so 2 into 1 minus x. So minus x 2, what we'll get from this? Minus 3x upon 2 into root 1 minus x as it is. This is f dash x. Now you need to get the next derivative, double derivative, f double dash. So again you differentiate it, f double dash x, second order derivative. Now how do we get the second order derivative? That is by you need to use the division rule here. So let's use the division rule over here. So if I use the division rule here, square the denominator function, 4 into 1 minus x. Your 2 into this much as it is, differentiation of this one. This is 0, here your minus 3. Minus, now which one as it is? 2 minus 3x as it is, differentiation of this one, 2 as it is, this differentiation of this much. What's the derivative of this one? 1 upon 2 root 1 minus x into by chain rule minus 1. I repeat division rule, square this, so 4 into 1 minus x, this expression over here as it is, differentiation of this one minus 3 minus 2 minus 3x as it is over here, differentiation of this 2 as it is, differentiation of root x, 1 upon 2 root x by chain rule minus 1. Now we little bit simplify this. This will be plus here, this 2 will get cancelled. Root is multiplied with this. This is minus 6. This root gives us 1 minus x. This minus and this minus gives us how much? Plus. And here you have 2 minus 3x upon, this is 1 power, and after taking LCM you are getting half power, so 1 and root half, that LCM, so it will be 3 by 2. This is f double dash. You can further simplify this numerator expression here. So the simplification over here is So it will be minus 4 minus 6 plus 2 minus 4 plus 6x minus 3x, so plus 3x, and this one as it is. Okay, so now we put this derivative equals to 0. Our domain is this. So now for f dash x equals to 0, it implies, have a look at f dash x, it is 2 minus 3x upon 2 into root 1 minus x equals to 0. So you have 2 minus 3x equals to 0, and therefore x will be 2 by 3. It is between 0 and 1. Right? Now we put this one in the double derivative. Double derivative f double dash 2 by 3. What is f double dash? You know, minus 4 plus 3 into 2 by 3 upon 4 into 1 minus 2 by 3 raised to 3 by 2. This is positive, 3 will get cancelled. But this expression minus 4 plus 2 is negative. That means f double dash is negative. Right? So second derivative is negative. First order derivative is 0 at 2 by 3. So therefore f has negative, means local maximum. Therefore f has local maximum at 2 by 3. And local maximum value equals to f of 2 by 3. Put x equals to 2 by 3 in the function. So what is the function here? That is x, which is 2 by 3 into root of 1 minus 2 by 3. So it will be 2 by 3 into how much? This is 1 by root 3. So you have 2 by 3 root 3. If you want to rationalize, you can multiply and divide by root 3 here. So you have 2 root 3, 3 into 3. So it will be 9. So this is local maximum value, 2 root 3 by 9. And it is at 2 by 3.